Now I'm going to give you one more topic, one important concept. 1 minute. Just give me 1 second. Wait 1 second. It's not working. Just give me 1 second. Once log out and log in again. Once log out and log in again. Yes, students. I hope you can see the screen now. Yes, students, please reply. I hope you can see the screen now. Yeah. Due to small technical issues, the drivers got missed. So just now I downloaded. Fine, let it be. So this is the concept what we discussed in the last class. Okay. So now I'm going to discuss about the new topic, that is mixed combination of cells. So keep this heading, mixed combination of cells. Yeah, keep this heading, mixed combination of cells. Yeah. In the last class, we discussed one concept. I hope you remember that. What is that means? Cells connected in series. What is the formula for cells connected in series? What is the effective EMF when cells connected in series? You tell me what is the effective EMF when cells connected in series? Yeah, please reply anyone. What is the effective EMF for cells connected in series? Yeah, E1 plus E2. Right. So cells connected in parallel, effective EMF for cells connected in parallel. Effective EMF for two cells connected in parallel. Effective EMF for two cells connected in parallel. Directly effective EMF will not get right. Effective EMF by effective resistance, that is equal to E1 by R1 plus E2 by R2, right? And effective internal resistance one. So here you will get like this. So effective EMF by effective internal distance is equal to E1 by R1 plus E2 by R2. And similarly, 1 by effective resistance is equal to 1 by R1 plus 1 by R2. So these are the equations. Now the next concept is mixed combination of cells. Here the next concept is mixed combination of cells. For example, I will take it as a cell. Now I'll take it as a cell with internal distance like this. Okay, I'll take it as a cell with internal distance like this. So there are some n cells. Now there are n cells with EMF E and internal resistance R, which are connected in series. Are you clear? For example, here we have n cells connected in series like this. Understood this point? No? We have n cells connected in series like this. And let us consider there is 1 minute, and there are one more row. No, there is one more row which is having again n cells connected in series. Clear? Again, we have one more row in which n cells are connected in series like this. Okay. So EMF is internal resistance are EMF E, internal resistance are E, R, and so on E and R. Okay. So like that, one more row is there. So what is that row means? Again, EMF E, internal resistance are EMF E, internal resistance are EMF E, internal resistance are like this. And so on, we have M rows. And so on, we have M rows. Are you clear? And please remember, in each one, there are n cells. In each row, there are n cells. Okay. And finally, this is connected to an external resistor of resistance capital R. Okay. Finally, it is connected to an external resistance of resistance capital R. Okay. For example, I'll write the question here. For example, here there are, for example, n cells in each row. Now, for example, there are n cells in each row and there are m cells. And there are m cells. Do you understand this point? No? So, n cells in each row. How many cells are there in each row? N cells are there. Okay. And there are how many rows are, and there are how many rows, and there are m rows. Okay, and there are m rows. Then what is the total current in the circuit and what is the EMF in the circuit? All these things now we are going to discuss. Now tell me, students, in each row how many cells are there? Tell me, in each row how many cells are there?
N cells.
N cells are there, right? Now what is the effective EMF of all these n cells? Now what is the effective EMF of all these n cells? Yeah, E3 plus 1. But all are same resistance, right? All are same EMF. So this is also EMFE, this is also EMFE, and this is also EMFE. So can you tell me what is the effective EMF? All are having same EMF. Then what is effective EMF? Yeah, N into E. So here effective EMF will be, no, here effective EMF will be N into E. Now can you tell me what is effective internal resistance? All resistance are connected in series or in parallel. Hello? Anyone is there? But do you have any exams, man? Yeah, then why they didn't log in? Okay, fine, let it be. Now all the cells are in series, right? Then what is the all internal resistance means all the internal resistance are in series. Therefore, n smaller is the effective internal resistance. This is for the first row. No, this is the for the first row. And similarly for the second row, effective EMF is now for the second row, effective EMF is NE and effective internal resistance NR. And similarly for the third row, you can write it as NE and this is NR. So and so on, how many rows are there? And so on, how many rows are there? M rows are there. Now this is finally connected to an external resistor of resistance capital R. Then can you tell me what is the current in the circuit? Okay. Now please reply. In this parallel combination, every cell is having same internal resistance and every cell is having same EMF. Now, can you tell me what is the effective EMF means? Effective EMF will be NE only. Why? Because all the cells are having same EMF. I told you one point in the last class. For example, if you take cells, now if you take any cell, for that cell, what is the effective EMF in parallel combination means? The cell with the highest EMF is the effective EMF. Did you remember this point? The cell with the highest EMF is taken as effective EMF. Did you remember, ma? In parallel combination? Yeah, I given one example also. 1 volt, for example, 2 volt, I will taken as 3 volt. For these three connected in parallel, what is the effective EMF means? Effective EMF is 3 volts. So effective EMF is nothing but highest EMF. Are you clear? Now let us suppose there are n cells in each row, then NE is the effective EMF. There are n resistors in each row, therefore NR is the effective resistance. Now if these are in connected in parallel, so NE all are in parallel, then effective EMF is NE only. Then effective internal resistance, can you tell me what is the value of effective internal resistance? How many rows are there means M rows are there. Now how many rows are there means M rows in parallel. Now there are M rows in parallel. Now there are M rows in parallel. Okay. And each row resistance is NR. Can you tell me what is the effective internal resistance? Yeah, please reply. Can you tell me what is the effective internal resistance? Yeah, tell me. More. Any idea? But tell me what is the effective internal resistance when N resistors connected in parallel? If N identical resistors are connected in parallel, what is the effective EMF? Anyone is there? Vidya is there? Very good. Ma, if n resistors are connected in parallel, ma, n identical resistors are connected in parallel. All resistance are R only. N resistors are connected in parallel. Can you tell me what is effective EMF, effective internal resistance? Array, easy concept only, right, ma?
N by R.
R by N. Correct? R by N.
Yes, sir.
Effective resistance is R by N. Now see, here how many rows I given means M rows. So M rows in parallel. M rows in parallel means, for example, R by M. So M rows in parallel means R by M. But what is the resistance in each row means NR. Therefore, this R can be taken as NR by, no, this R can be taken as NR by M. Did you understand? So we connected M rows in parallel. Please remember, we connected M rows in parallel. Therefore, effective resistance can be taken as R by M. Now, what is the R value in each row means NR. Then we know that current I is equal to E by capital R plus small r. That can also be taken as E effective by R plus small r effective. Okay. Now tell me what is E effective value. Now tell me what is E effective value. E effective value is NE divided by R plus small r effective is small n R by M. Then that can be taken as I is equal to NE divided by, take cross multiplication, MR plus NR. And this M will goes to the numerator. That is MNE by capital MR plus small nr. Okay. So please do it. Then I will give you some important concept based on this. Is it done, ma?
Yes, sir.
Yeah, fine. Now listen. Now the condition to get a maximum current, what will be the condition? So in the previous concept also we discussed to get the maximum current, we wrote some condition. Here also, to get a maximum current, what will be the condition? But to get maximum current, what will be the condition? Once verify current with the internal resistance, then you will get an idea. Yeah, please reply, students. In the previous concept, we discussed like this. To get maximum current, what is the condition to get the maximum current? Hello, anyone is there?
Capital R is equal to small r.
Yeah, capital R is equal to smaller. So in the same way, here capital R and smaller in the numerator, right? So tell me, in order to get a maximum current, please remember, to get the maximum current, what will be the condition? What might be the condition? Just think. MR must be equal to N smaller. Please remember this. Okay, na? Understood this point, no? And remember, this Mn is taken as number of cells in the complete circuit. Here Mn can be taken as what? Number of cells in the complete circuit or whole circuit. Okay. Now listen. Based on this, how the questions are going to ask, I will give you an example model problem. I'll give you an example model problem. For example, the question is like this: 36 cells, clear? Each of EMF E. 36 cells, each of EMF E are connected. Okay, in rows. Okay. sorry, each of EMF, sorry, 1 minute like this, you just write like this. Each of EMF E, and just include one point, just include one point, each of EMF E and internal resistance, 1 minute. Yeah, each of EMF E and internal resistance, okay, and internal resistance, clear, and internal resistance 0.5 ohm, okay, are connected, 1 minute, are connected to an external resistance of resistance 2 ohm, okay. 1 minute, you are writing the question mark. Yeah. External resistance of resistance 2 ohm, are you clear? How many or what are the number of rows, or what are the number of rows? 1 minute, the question is what are the number of rows and cells in each row to get maximum current in the circuit, okay, to get maximum current in the circuit. So this was the question, okay. If you write the question, I'll explain the answer, I'll explain the solution. Yeah, shall I explain the answer?
Yes, sir.
Now tell me, how many cells are there in the circuit? 36 cells. So the 36 cells we should take, the 36 cells we should take Mn. So Mn is equal to 36 cells. But tell me, to get maximum current in the circuit, what will be the condition?
MR is equal to NR.
Yeah, very good. M smaller or M capital R is equal to N smaller. This is the condition. And remember one more point, students. We should find out each row and number of rows. Clear, cells in each row and number of rows. Cells in each row means a small n. Number of rows means small m. Okay, this is what we considered in the previous question, previous concept. So m is number of rows, n is number of cells in each row. Then condition is mr is equal to nr. Then you can write m into r value is 2 ohm, that is equal to n into smaller value 0.5. But please remember, whenever the problem is given in decimals, try to convert in fractions, then the calculation will be very simple. Then 0.5 ohm can be taken as 1 by 2 ohm. So that can be taken as 1 by 2. So bring 2 here, then 2 into 2, that is 4m is equal to n. Did you understand this point? No?
Yes, sir.
Yeah, take it as equation number 1, take it as equation number 2. Then please remember, substitute equation number 2 in equation number 1. Then you can write m into, in the place of n, I will substitute 4m, that is equal to 36. Then you can write it as 4m square is equal to 36. Cancel 4 1s are 4 9s are 36. Then m square is equal to 9, or m is equal to plus or minus 3. This is the answer. Okay. So 3 means, can you tell me what is the value of n? Then what is the value of n? N is equal to 36 by 3. That is equal to 12. So how many rows we have to connect in series and parallel? Yeah, how many rows we should connect, or how many cells in each row?
Cells in each row 12 and number of rows are 3.
Yeah, so in each row we have 12 cells and we have 3 rows. This is the concept. Okay, so problems will be like this based on the mixed combination of resistors. Then if you're done with this, we'll go for the next question. Yeah, shall I move to the next concept now?
Yes, sir.
Now keep the citing Kirchhoff laws. Now keep the citing Kirchhoff laws. In that first one, Kirchhoff first law, or this is also called as junction law. Okay, Kirchhoff first law, or else this is also called as Kirchhoff junction law. What is Kirchhoff first law means? The algebraic sum. Clear, the algebraic sum of currents, okay, entering into the junction is zero. Now the algebraic sum of currents entering into the junction is equal to zero. Clear, the algebraic sum of currents entering into the junction is equal to how much more? Zero. Or we have one more definition also there. The sum of currents entering into the junction, the sum of currents, okay, entering into the junction, okay, the sum of currents entering into the junction is equal to what, mark? Sum of currents leaving the junction. This concept is over in your college.
Yes, sir.
Yeah. So the sum of current entering into the junction is equal to the sum of currents leaving the junction. This is the Kirchhoff first law. Am I right? This is the Kirchhoff first law. So for that one, some example also we have taken. What is that means? For example, if I take some 5 resistors like this, or else if I take some resistors like this. So if I take some resistors like this, these are the resistors. Now current through this resistor is I1, current through the resistor is I2, current through this resistor is I3, and this is the junction. So sum of currents entering into the junction is I1 plus I2 plus I3 is equal to sum of currents leaving the junction. This is I4, this is I5, which can be taken as I4 plus I5. Okay, so this is the Kirchhoff first law, or else you can write like this: I1 plus I2 plus I3 minus I4 minus I5 is equal to 0, or sigma you can take like this: I. Okay, so first we will take the sign conventions across the resistors. First we learn about sign conventions across resistors. Okay, now please remember, I'll take it as a resistor. I'll take this point as A, I'll take this point as B, I'll take this as resistance R. Now current is flowing from A to B. Now tell me, which is at high potential, which is at low potential, A na, B na? Now listen, current is flowing from A to B, which is at high potential, which is at low potential.
A. A is at high potential.
Yeah, very good. Then potential at A is greater than potential at B. Then only current flows from where to where, A to B. Now please remember, for example, if we are also moving in the same direction. So current is moving from A to B. We are also moving from A to B. Okay. In such case, the product of current and resistance, the product of current and resistance is always taken as negative. Because we are moving from high potential to low potential. Now, please remember, when we are moving from high potential to low potential. Okay, please remember, whenever you are going from high to low, that is always taken as negative. For example, in 10th you scored 100 out of 100. In PU you scored only 90. So you move from high to low, then that is nothing but negative. So your improvement is negative like that. Okay. So here also we are moving from where to where, my A to B. A is at high potential, B is at low potential. Then the product of current and resistance is taken as negative. Please remember this. And similarly, I'll take it as a resistor. Okay, I'll take this point as A, I'll take this point as B, I'll take it as resistance R. Now current is flowing from A to B. Now tell me which is at high potential, which is at low potential.
A is at high potential and B is at low potential.
Yeah, very good. Then this time I'm moving from B to A. Then the product of current and resistance is taken as positive.
Positive.
Okay. These are the NCERT standard notations, but in some other books they given in opposite also. You need not worry, but listen this, but try to remember this. This is the sign conventions across the resistor. And similarly, we have sign conventions across the cells also. Now we have the sign conventions across the cells also. For example, if I take it as a cell with EMFE, this is positive terminal, this is negative terminal. For example, please remember students, I am moving from positive terminal to negative terminal. Now, positive means high potential, negative means low potential. Always you have to move from, okay, in your life also, you have to move from 0 to maximum, which means that you have to grow in the life. Okay, so growing in the life is positive. So if we didn't grow in the life, that is negative. So we are moving from positive to negative means high growth to less growth. Therefore, our growth is negative. You can take that EMF as minus E. And similarly, I'll take it as a cell. I'll take it as a cell of EMF E. And this is positive, this is negative. We are moving from negative terminal of the battery to the positive terminal of the battery. Now we are moving from negative terminal of the battery to the positive terminal of the battery. Then EMF is taken as positive. Please remember this. Okay. So you try to by heart or understand or else remember these two concepts, then we will do some problems based on this concept. So which kind of problems we have to apply based on this Kirchhoff law and all, I will tell you, then you will understand easily. Okay. So please note these points. And for today, you just by heart or remember whatever it may be, do with this, register some cell, and then we'll go for the problems tomorrow. Okay. So I'll take the class tomorrow, the remaining class. And sorry, due to technical issues, first 10 minutes or 20 minutes I can't take. So please do it more. Do it and you may leave the class.
Thank you, sir.
Yeah. Okay.
Thank you, sir.